Okay. So today I am doing some tracing. I got some new surface predictions from scroll 3, 4, and 5. And I'm going to try to make some new segments. I started yesterday with seeding, and I got, let's see, about 7,900. Actually, apparently it must, I'm running one right now. I'm running a trace right now. That's why it's going up. So right now you can see I got this one going. It has been in progress for probably 45 minutes or so now. Let's see how big it is. I made this little conversion script here because it just spits it out in voxels squared, which is kind of hard for me to visualize how big it is. So I just punch in it is. This trace is going from the outside in, so left to right. The right is inside, and what I've done here is connected to another one that I did earlier. I marked as approved, and this is a new functionality that Hendrik put in Saturday, I think, where you can connect full traces as if they were patches. I'll try to do that here in just a second. Just want to check and see if we've got any obvious errors. What's surprising to me is that I'm not seeing. Where did that go? There it is. What I would have expected to see in here is a lot of things that say found approved. And so I fear that it did not mark mine as approved. So I gotta go through that. And that's likely, no, I did mark it as approved. So maybe I just haven't gotten to it yet. If I look at where this one is, by just control clicking the point there, well, I should have by now. Let's see where we're at. So this goes out to about there. So we should be there or very near. So we should have found them by now. So maybe I just spoke too early. Oh no, I think I know what the problem is. Hey Forrest, so to run these ones as approved, you also have to generate ones that are overlapping, and I don't think I did that. All I'm doing today is just doing a bunch of traces. I got new predictions on scroll 4, so I'm trying to unroll it. I think the predictions are good enough that I can unroll all of scroll 4. I'm pretty sure. So I'm going to try to do that today. I need to find out why I don't know when you joined. I missed, for some reason my thing didn't make any sound, but Hendrik added some functionality to VC3D where you can use traces that you've generated previously as essentially as patches, but you've got to do you got to do a couple things for that to work, and I think I forgot to do part of it. I did. So I got to stop this one. So I have to run a command that will generate a patch. Each patch that gets used during the tracing process has information in it right here. So it's just overlapping, which is all of the traces that overlap it. or not all the traces, but all the patches that overlap it. And by default, traces don't create that data because it's kind of expensive and there's just really no point all of the time. They're not really intended to be used as solely as patches, but you can use them as patches if you add that information. And so I have to do that, and I forgot to. I think I got it in this one. Yes. That one's just called VC seg add overlap, so I have to add that to the guide too. And this one's called. You have to start them with the name autogrown as well. Then I got to go through and delete my old trace that I had done before. So I'm kind of playing around with this new functionality because it opens up some kind of interesting ways to trace. So previously you would always just run a trace and then mask out the patches that were wrong and then go back and run the trace again and kind of do that same thing over and over again. But this could allow me to just basically make like a bunch of really large and good patches, like say like 5 or 6 of them in different ranges of the volume, and make sure that they have no errors at all, and then run a trace, and all of those ones that I mark as approved will just get added instantly. Oh yeah, Nipari's awesome. I really like Nipari, and it's so fast to add functionality to it. You can just like any Python function, you can just literally turn into a GUI widget by just decorating it with @magic GUI, and boom, you've got another UI element that can interact directly with Python. It's amazing. So that should work. And if you know how to use Qt at all, you can design your widgets in Qt Designer, and then still use Magic GUI. You just import them with Magic GUI, and you can make really nice, quick UIs to do all kinds of stuff. And then you've got access to your points, you've got access to your labels layer, your points layer, your image layer, and everything, all in one. I'm a huge fan of Nipari. I'm also, at the same time, running new seeds on scroll 3 because I've got new predictions for scroll 3, and I'm also generating ZARs for scroll 5. I'm going to run new traces in scroll 5 as well. Probably not today because scroll 5 is huge, so it'll take a little while to seed. I need to... I have the new scroll 5 preds in a ZAR. I need to turn them into an OME ZAR. Hey, Polytrope. What I'm doing now is just running some new traces on scroll 4, which I got running in the background here. And I have new scroll 5 predictions that I am going to be turning into a OME ZAR volume, so I can start seeding that as well. So I can hopefully make some new scroll 5 traces, maybe tomorrow. And I'll show you, you in particular are probably interested in the ink part that I showed earlier, so I'll show you how to do that too. It's also very, very easy. And then I want to do no. What is .py? Yeah, it uses OpenGL, so it can be kind of annoying if you use really large images, because OpenGL has a maximum a maximum image size, it just won't go over. But 1024 by 1024 is more than enough. Yeah, it does just great on that. It can render a whole ZAR. You can drag a gigantic ZAR into it, and it'll just lazily load it, but it'll be slow. It uses Dask as the backend, so it'll lazily load H5 or ZAR. You can just drag the ZAR file right into it. If you ever get this error, by the way, with ZAR, it's because you're using a new version of ZAR, which took that away. Yeah, well, so you can do that though with Dask. So that Dask is amazing. It's actually one of their demos here. I'm just going to show you that real quick. You can do lazy pre-computing with Dask too. So you do it chunk by chunk as you visualize it. Dask is awesome. If you're in Python, I would take a look at it. But there's a example here where you can load an image and then run a pre-processing step on it lazily, so that only the ones that you view get that stuff run on it too, which makes it really nice if you're like kind of spinning up a like a full pipeline and you want to visualize it in a bunch of different areas, but you don't want to have to like pick different chunks to do it on. And if you want to reshape ZARs and stuff too, it's good for that. I just had to, let's see if I can find it here. I think I just called it reshape ZAR. Yeah, transpose ZAR. So like Ryan's ink detection is in XYZ, and everything that I have is in ZYX. So you can literally reshape a 10,000 by 10,000 by 10,000 volume by just loading DA from ZAR, transposing it, and then just doing DA to ZAR. And it'll do it completely lazily, extremely fast, and use like zero memory. It's insane. I love Dask for especially for this kind of thing, because you can wrap anything that you can think of in a delayed Dask call, and it'll just order that on the graph and do it all lazily. But I mean, that's what, like five total lines, and two of them are the main block. So it's pretty nice. Oh, yeah, I was going to close that and reload it. I kind of want to see where that one's at now. And then I'll pop up a scroll one volume so I can show what that ink looks like. I really think that this is, if you're looking for a way to get a ton of ink training data, I don't think there's really a better way to do it, or find letters. It's like instantaneous. I have scroll. No, I started from the wrong spot. Whatever. We'll just go from there. We'll see what happens. Yeah, you can on some of them for sure. You get an eye for it. It just takes a little while. If you do any kind of ink annotation long enough, you start to get pretty good at catching it. But this is like what scroll 4 looks like, so I'll render it. I say render, but it's not really a render in the way that we've understood it before, but it might as well be. So I'll just show it in, this is my ink volume, which is the one I ran quite a while ago, but it looks a lot different in scroll 4 than what the rendered segments look like for ink detection. Even though mine does quite well on scroll 1, the way it looks on scroll 4 is considerably different than the way any of the other models look like on scroll 4. It doesn't pick up a lot of things that other ones do. It's not as tricked by certain things, but it also isn't probably as good. But it's hard to say. I masked it out for air, so it doesn't like mark the surface as much. And if you look at like some of these here, it doesn't mark those like huge plates really. So I actually think that a lot of these are letter parts, but I don't know. I can't put them all together. And this is the thresholded probability, so it's only the stuff over 50%, and so you get this kind of like broken up way it's displayed, and it's hard to piece things together when you've just got these kind of little like chunks. I'm hoping that when I do my next training run here that I can get a little bit more out of that. And then I have Ryan Chesler's ink volume loaded in here as well, and that's what this one looks like. But again, it's a very different look at these than the actual ink detection on the surfaces. And I think in some cases, maybe it could provide some insight into some things that those don't. It's hard to say. It's worth looking into, for sure, if you're looking for ink. But the best part about it potentially is that you can pick whatever you want. I have like, 8,000 patches in here, and they're from all over the scroll. So even if I don't have a segment, even if this trace doesn't go for the entire scroll volume, I can pick any of these colored patches and I can just literally tab through them and essentially see pre-computed ink detection results for every single surface in the entire scroll, which might be an easy way if you're looking through ink. If you're trying to find letters in one of these things. Early on last year, when me and Ryan ran these, me and Ryan and a couple other people were on a team early in the year that didn't end up working out because a lot of people just had stuff come up. But this was one of the main ideas that we had, was try to find a way to extract and basically do exactly what I'm doing right now, pre-compute the 3D ink detection for the entire volume, and then just extract patches and just tab through them and look for letters. And I think that this is a really good way to do it. If you're looking to make 60 grand, I think that it's likely that in, at least as far as I'm concerned, I would imagine that in every volume there is areas that have ink that is much easier to see than in other areas. That's true in scroll 1, that's true in scroll 5. I don't see why it wouldn't hold true in scroll 3 or 4 or any other scroll. Why there wouldn't be certain spots that have more, maybe the ink was thicker when they laid it on, or there was charred less, or the way the scroll was laid, whatever reason. I would imagine that every scroll has areas that probably are easier to see. And so doing this is probably a good way to do it, and also to get training stuff on ones we have it already. But what I like about this too is, like I said, the 3D models don't tend to pick up the really like big plate crackle as badly. So like if you look at this on like a surface model, like the GP one, it picks up a lot of that surface crackle on scroll 4. That's like that really thick plate stuff, and it makes sense too because it looks exactly like crackle, but it doesn't on scroll 4. It doesn't seem to directly correlate to ink, and so I don't. It makes it hard to see. What I think is going to happen when we have letters on these scrolls is we're going to go through and look at the ink detection predictions we have already, and we're going to probably be like, oh my god, we've been staring at letters for a long time, but there's just so much noise. I'm just letting that one run. I'll pull up scroll 1 here in a second and just show you what that looks like in one where we have good ink detection. I don't have these 3D predictions on scroll 5 yet. I'm going to train a new model, a new 3D model with some extra augmentations and a few other things. Like that. What is this? Yeah, that's a scroll volume. I'm just curious what it's picking up here. Make sure my trace is running. Yeah. So that's mine. Ryan's was the one that looked interesting here. And his is hard to see sometimes in these. It's got a lot of this like checkerboard pattern, but it is lighting up there. Well, let's keep moving. His is very good in scroll 1 though, so I would imagine it's also good here. If there is any translation. But this too is why if we have 3D labels on the surfaces, we can map those back to 3D, project those back to 3D, and actually localize the ink signal. And then our ink detection is totally separated from segmentation, and we can pre-compute ink detection on every scroll immediately, and not have to run it. You don't have to do that pipeline of you make a segment, then you got to run ink detection. You got to wait that whole time. You can just make your segment and see the ink detection as you do it, which will be awesome. But if we had 3D labels, so a label for the signal on each layer rather than a single flat label that we just project through the layers, we would have extremely accurate ink, I think. But we might lose a little bit of signal too, because we don't know exactly what that signal is. That's kind of the problem, and that's a big reason we've done it a lot of the way that we have, is because we don't really know exactly what the signal is. Yeah, trying to piece together things like this is tough, but I'll do this for just a little bit longer here. The reason I'm switching through mine and Ryan's is, although mine are more picky. Ryan used a thing called an ignore label, so he only computed loss against his label, and as a result of that, it has no negative examples, and so it doesn't mark. It's very hesitant to mark anything as directly not ink. It does mark some things as that, but it's very, very hesitant to do that, and so it's sometimes hard to see in areas that it's not really sure of, because it won't really mark anywhere as like absolutely not letters, but it's very confident here. Kind of curious what the underlying surface here looks like, because both of our models got that. Let me get a little bit of a texture there. Is that the spot? No, it's like more up here. The only problem is I can't tab through the layers, so I can't get down and maybe see if that signal comes from a little higher or a little lower. But you can render these if you did find a spot that you were like, okay, I'm pretty sure those are letters. You could render both the ink detection volume, which would give you the 3D ink detection, and you could also render the actual scroll. And that looks quite interesting. Where are we? About 2/3 of the volume. Also, you can't rotate it, so I got to tilt my head. Well, I should have that part segmented here soon, so I might now actually, so we can get a bigger look at it. And this is the other thing that's really nice about doing it this way is if you go, oh, I wish that segment was just a little bit bigger. You can just make it bigger, and you can see it immediately. You don't have to really do anything. So we're about, I started this trace, I don't know, 15 minutes ago. And we are, where's my little conversion? We got 104 centimeters. David asked me earlier how fast this process goes, and I didn't have a good number. I still don't really, because the better the prediction, the better this goes. I think that one that we were looking at before was down here. But I like to kind of zoom out. Problem is, there's just so much here until I get a better ink detection model, or until I run until I export the softmax of these. It's just so hard to tell. There's just so much noise. But there's so much that looks like letters, like that. This is upside down, though, I think. I think the scan for scroll 4 is upside down. And this is flipped. So I've got three things working against me. Noise, orientation, and perspective. Thankfully, most of the Greek letters are pretty identifiable. At least if they stand out. Although this one might be in Latin. Let's pull up scroll 1. Scroll 1 is going to take quite a while to load. I have 67,000 patches in here, and we'll have to wait for it to go through those. So it'll probably be about a minute or two. But this way of looking for ink is both effective, and then also, like I said, I mean, you can grab patches. I'll render one here just so you can see what that looks like. You don't need a graphics card for it either. You could render it. It doesn't take a lot of like compute or anything, especially rendering just a patch. You could probably render a patch on your computer, like on a cheap laptop, in a couple minutes, if that. And you also wouldn't need to grab all 67,000 patches if you didn't want to. You could make this load quite a bit faster if you just kind of cut that in half or something. I'm going off of this, so it would probably help if I type scroll prize, right? I believe if I go into fragments here, and this could be incorrect. So this is this one, fragment 5, P.Herc.1667, and then somewhere is it says that it might be in Latin. I gotta find this. Is there not segments? Wonder if I can find it now. I just asked Steven this the other day because somebody on Twitter asked me if there were any scrolls in Latin, and he said he thought that maybe scroll 4 was, if it comes from that fragment, but we both could be incorrect there. I'm trying to figure out where I got that information from. I don't know where that was. Somewhere on here it was. I'll dig it up too. It's somewhere. Somewhere it says something. That's as good as I could get right now. This is scroll 1. So this is the trace here. This is the V4 trace that Hendrik uploaded. And then it's currently looking at the surface predictions, but if I load up my ink, we can see just the rendered ink volume right on here, and then you can see the letters pretty well, which proves out that the 3D ink detection does work. It's not, because I don't have softmax outputs, it's a little bit harder to read here, because you don't get any gradient really. Like on the normal predictions, it outputs all the probabilities that something is ink, and that gives you kind of a gradient that localizes the letter a little bit better than just this really bright single blob. So these ink predictions are probably nearly as good as, or around as good as, the grand prize one, but they're just not, I mean, they were trained with pretty much all the same data, and when you compare them directly, they look very similar, but it's very hard to see them. It's very hard to look at them because like you just get these kind of like blobs. You got to zoom out a little bit, but when you do that, it becomes very apparent. I think that they do get some different spots as well. Yeah, fragment 5 does look weird. All of scroll 4 looks weird. I don't know. I talked about that, I think, in the last one too, but that I'm pretty convinced, and I don't know that that's 100% true, but I'm pretty convinced that the method of unrolling them and like the kind of treatment that they went through in that process might have had an effect on some of it. But let's pull up a couple patches as well, and then I'll render a patch quick just so you can see what that looks like. So let's just grab a random spot that is not segmented. Also, this is what the volume looks like. Let me just quick click somewhere where there won't, if I click filter on focus point. The ink volumes look like this. So each one of these lines is a letter. You can see the scroll 4 or the scroll 1 volume is quite full. This is the whole volume, so we've got letters pretty much everywhere throughout the volume, which is good to know that at least 3D ink and presumably everywhere that we've segmented, the grand prize model can get it. So we can get ink pretty much wherever we want once we have reasonable ink detection. I'm going to grab a decent size one from out here. Let's see, that looks like there's some solid letters. But then we can just tab through them for a little bit. Maybe you'll see something interesting and I can render it right away. We could look for the title actually too, maybe. I didn't mean to change that. That's the fun part about the ink volumes being loaded in VC3D like this, is you can very quickly just like look for stuff wherever you want, and you don't have to render it or anything. You just have it immediately. There it is. So let's look through a few of these. So like I said, they're a little bit harder to see. I'm actually gonna render, I have Ryan's downloaded too. Some of these are pretty small. I was hoping I had some bigger ones in here. The bigger they are, the easier they are to see, but yeah, you can see letters throughout pretty much all of them. I want to find a nice big one from outside of the grand prize region that I can render, and then I can just put out right away, and then we can see what's on it. I'll just tab through these, and we'll see if I can just keep an eye on ones that are outside the grand prize. This volume has so much, so many patches in it that it's really hard to see where these are. And actually, I'm going to transpose this one right now. Ryan's might be a little bit easier to see in scroll 1. And where did I save that? Volume packages, I think. And I'll upload the transposed versions as well, so that you can, because if you try to load one of Ryan's right in VC3D, the axes are out of order, so it won't work right. But I'll upload the transposed ones, which I also converted to Uint8 and compressed, so they're way smaller. This is another cool part about Dask, by the way. If you run it as if you import the client and you start the client that way, you get a dashboard, and from that dashboard, you can see. It takes a little while to load because I have a million things running on my computer right now, but when it does load, oh. What's going on? Oh, it's a huge graph. That's why. But there you go. And now you can see everything run. You can see kind of nice, big, shiny colors, but you can see the progress and every task that it's doing. I kind of like watching it. It's fun. And you can set your client if you do right now it's a desktop distributed client, but if you did like local client, you could do client equal, I think it's just local cluster. No, it's cluster equals local client, and you can set like memory per worker, number of threads per worker, maximum total memory, all stuff like that. And Dask also has a CUDA cluster option, so you can do all of that on GPU. You could use Rapids AI or Rapids CUCIM, which is essentially a scikit image wrapper of or a CUDA wrapper of scikit image, and so using like those three together, you could have a completely GPU driven distributed hard drive on arrays of whatever the hell size you want, which is freaking awesome. And you don't have to do anything. You just write scikit image code. You don't have to write chunk stuff. You don't have to do anything. We'll wait for this. No, we won't wait for it. Because once this finishes, actually, I've got to then turn it into an OME ZAR. Because it's just a standard ZAR right now. So it's going to take a little while. But we'll just tab through some of these until I find a pretty good size one that's not in the grand prize. And then we'll render it. Right. Yeah, it would be nice if it were easier to find. Charts is pretty cool how many things are on there, but it's also kind of hard to, you can't really sort it very well, or at least I haven't figured out how to. I wonder where this one is. I was going through there a lot, like a year and a half ago, towards the end of the grand prize, because I was trying to find out I was trying to figure out who the author was of scroll 1, and I found a bunch of ones that looked very similar, but I don't know. I'm not a papyrologist. Long story short of it is I was just on there for a while, but there might be more like You might be able to sort it a little bit better than I did. I also always have to translate it from Italian to English. Yeah, there really isn't very great sorting on there, is there? I guess I can do this. So that's within the grand prize. Ooh, hopefully this one's from outside, because that one has a fair chunk. My computer is very slow to respond right now because I'm killing it at the moment with a lot of different things. I'm running seeds on scroll 3, I'm transposing a gigantic array, I'm running a training, and then I'm trying to load through 67,000 patches at once every couple seconds. So it will be a little bit slow while we go here. I might just turn the scroll 3 seeding off for now. Give it a little bit of breathing room. But even doing all of that, I'm only using 41 gigs of RAM, which isn't bad. Alien 2, I was going to show you. I have that new data set. I uploaded it to write, and I'll make a post about it too. Not scrolls and in unit models, raw 7.0. I'll send a link right here. So these are those 320 size ones, and they are they're a little bit different than the other one in the sense, well, first off, they're much bigger, but also I pre-computed a lot of augmentations on them, spatial augmentations primarily. I did some grid transformation and then arbitrary angle rotation along with random 90-degree rotations. And the reason I pre-computed them is because they take forever in training, and I don't want to deal with that. But if you don't want to do them, if you don't want them pre-computed, you can rip those ones out pretty easily. They have a prefix of aug. So like if I go to S4 aug, and they look kind of funny in the preview because the first and the last layers, because they're random rotations, and I didn't want to mirror the things, and it's no longer like perfectly square because this one's rotated some degree this way and some degree that way. So they look a little funny sometimes, but I did that ahead of time so that I didn't have to pay that compute cost during training. But if you want to rip them out, they just have aug in them, so you could just type aug and literally delete all those, and then you wouldn't lose. They're just copies of the other ones. So you're not going to lose any training data, but both the images and the labels have that applied to them. So let's just render this one. Then I can literally upload it right away. .5.3, right? Yep. So rendering with VC3D is pretty easy. It's just an app within VC3D. You don't have to like leave VC3D and open up a different app or do anything like. It's not GUI based, but you don't have to. You don't have to do anything crazy. I have way too many notepads open. So we'll render this one at full res. The one we're looking for is auto grown. Every time you click on a surface, by the way, in VC3D, it prints out this on the terminal, which is pretty nice if you're trying to find the path of the one you want to render or the one you want to use as a seed. So the command is just, this is the path to the app, I don't have it on my environment variables, so I have to enter the full path, but that's fine. This is the path to the volume that you are targeting to render from. This is the path to the layers directory, or where you want to actually output it, and then this is the path to the target segment. 1 is the scale, 0 is the resolution, and 21 is the layers. So I want to render 21 layers. And we will render it from the ink volume first. So let's actually change this to layers. Ink. This should render pretty fast. It'll be a little bit slower because of the amount of things I'm doing right now, but yeah, I wrote it out to the pass, autogrown 9653. I should have wrote that somewhere else. I have multiple 9653s, don't I? Yeah, there we go. It's done rendering. So you can see it's really, really, really fast. What's going on here? I need to give my computer a break. Alright, so there's our ink layers. Let's pull up Napari and see if we can't get a look at what the ink layers look like in there. I've actually never looked at a 3D render. I've never rendered ink layers out like this, so I don't even know what this will look like yet, but we'll find out. I'm also going to just render the volume so we can look at both of them at the same time. The volume should be pretty quick too. I just have to remember what my volume is named. Yeah, S1 and 8. So all I got to do is replace my target volume here, scroll ink .zar with the U and 8 .zar, and then make sure I'm not calling that layers ink, which I'm not, and we will render that, and then we'll rip it open in Apari and take a look at it. And then I'll actually just upload it right away. It's probably flipped. It looks like it's flipped, but this is another one from pretty far out. I'm kind of curious to see what this looks like anyways. I segmented a fair bit out from the grand prize in that like outer 40 area. When I started segmenting, so I started with annotation and then I started segmenting, and I asked the team early on like kind of where they were interested, and that was a big region they were interested in, was because there was a lot of, you can see visually as you go through there on the outside that there's a ton of crackle, and so we wanted to kind of get some eyes on that. So I've done a fair bit of segmenting out here, but even the fair bit of segmenting that I did is, in terms of the total volume, is like nothing. So a lot of these areas are the first time I've seen them. So it's kind of fun to render these and take a look at them. This one will take a little bit longer to render than the ink did, but not much. Let's pull up into Apari and see what the ink layers look like. In Apari, you can just drag a folder, by the way, too. If you've got a folder of TIFFs, you just drag the folder of TIFFs right in there. Got a folder of images, drag them right in there. And it just loads them as a 3D volume. And then we'll just change this to labels, and now we've got labels. So Apari's very, 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 very handy if you're looking to do things quickly. It's not like the best for everything, but yeah, so we've got like 3 labels, actually, which is fantastic. It's not as visible, again, as the the full surface volume one, but it doesn't have as much training data either. So we're hoping as we make these 3D models better, does Nipari chunk loading well for native resolution volume? Yeah, no, it does. It lazily loads it. So you can do, you can drag literally a 10 terabyte ZAR into Nipari, and it will only load what you're looking at. And it has native support for OME, but it's next generation file format. So an NGFF, OME, they're like partnered together to make ZAR and H5 or N5. They have like a set of standards for the resolutions, and Nipari's compatible with them. So when you zoom out past a certain amount in a lazily loaded array in Nipari, it will only load like the lowest resolution, and then as you go in, it'll load the higher ones. It does all that natively with Dask, so it's all lazy. You don't ever load all of it. Even TIFFs too, actually. Even if you loaded like literally the single TIFFs into Nipari, just drag the entire volume of single TIFFs in, it uses Dask for that too, and it'll only load the layers that it needs to. It will be very slow because it's going to have to load, obviously like a 1 by 6,000 by 9,000 slice of an array isn't really a good access pattern, but it will work, and it won't take up all of your memory. I'm just kind of looking around here. I always like to look in these outer areas, especially like what does the ink even look like out here, because it's different. It's different everywhere. This one's fun though. We get a lot more as we get out. You can see kind of you see this on the fragments more, but it's still crackle, but it's more like, I'll just draw it because it's kind of hard to see my thing. It's still crackle, but it's very, very, oh yeah, I have an array open, so I can't slice on it. That's one thing. If you open a folder like this, you can't draw on them all the time, but I might be able to just make a new labels layer. Oh yeah, so like right here, it's still crackle, but it's kind of like see-through almost. And you see some of that as we get in, but a lot of the fragments are like that. So I got this one rendered. I'll upload it right now, and then if somebody wanted to train with it, they can. But I'll do a couple of these, and then I'll go back to scroll 4. We'll see where scroll 4 is at. Well, actually, I'll just go back to scroll 4 after this one. Let me upload this quick. We'll go to scrolls, scroll 1. We have segments. I've never actually made an autogens one for scroll 1, so I'm trying to do the same thing in all of these scrolls where I make I have a manual segmentations and then an autogens one, and the reason for that is I just want to separate out which ones are which, because a lot of these autogen ones are kind of like in progress. They're not infilled. They're not necessarily made with 100% of a focus on like surface quality. The biggest reason that I'm putting them out is because they have data that's useful, and I don't want to throw it away. Who knows, the next time someone will create a segment where I just did, and it would be a shame to throw it away because it's good training data. And it's not huge, but it's better than nothing. So we'll see where my trace is at for scroll 1 now, or scroll 4. We're still growing. That's uploaded now, by the way, if you wanted to get that. 147. We can take a look at scroll 3 too. Scroll 3 is fun. Scroll 3 is the most interesting to me right now because we don't have a ton from scroll 3. We have hardly any segmentations at all, and so I really like going through scroll 3 because it's like you're the first person looking at it. Scroll 4, I've looked at scroll 4 forever. We've had segmentations to scroll 4 of a lot of it for a long time. but not scroll 3. And so I'm really excited to try to get like a huge segment in scroll 3. I just saw that message. Yeah, same thing. Exactly the same thing, Alien. Yeah, just doing it ahead of time so you don't have to do it after. And it's nice because you can get a better look at it. I like pre-computing stuff sometimes because you can see it right away. You're not wondering what it looks like, during the pipeline, because otherwise, you import volumentations and then you enter that, but then you don't really typically look at it that much. You just let it run, and if it doesn't, if it has decent loss, you assume everything's going well, but you don't ever really know for sure if your augmentations are doing exactly what you thought they would. You should look at it, but I don't all the time. Sometimes I trust the computer more than I probably should. I'm hoping that data set will be good, though. Those are 320 cubed, which is a pretty big volume for a machine learning model. The biggest I've done yet is 224 by 224 by 64, I think, was the largest one I've done so far. So it's quite a step. Hopefully we can get this to load a little bit quicker here. The more things that you have in this, the slower it loads. Although I'm realizing now, I think that I loaded scroll 1 again. And I don't want to look at scroll 1 again. I want to look at scroll 4. Let me send to, I'll get these other ones uploading. So I want to get Ryan's ones uploaded. I want to, I'm trying to make this part like really quick and easy for people if you wanted to start in VC3D, where like I have all of the pre-computed data, all of this stuff in a good spot where it's easy to pull up. So if you wanted to like go through and look for ink, you can just literally download the couple things there. They're transposed properly. Everything's set up for you already. And you can just get started. You don't have to do any of that. That's also why I have a lot of the patches uploaded, so you don't have to seed the volumes if you don't want to, because that takes time. So right now, like in scroll 1, and I'll upload the new stuff from scroll 4 and scroll 3 and my new ones in scroll 5 when those are available. So you don't have to just sit and wait. Oh, sweet, yeah. I'm curious to see how that looks. Yeah, the trace is like, because the seed's like, if you seed a volume, like if I seed this whole volume, and I run it for 3 full days, and I got 100,000 seeds, there's no point in you doing it too. You're not going to get like it's not going to be dramatically different from when I ran it. So there's no point in every single person who wants to run VC3D generating 80,000 seeds and burning their computers up for 3 days. It doesn't make sense. So I'd rather just, I can do it when I generate the predictions, the services, I can upload them. Granted, some of them don't have, some of them aren't as densely seeded as they could be. And so it's good to know how to do it, because sometimes you'll run into areas where your trace keeps dying because maybe this part here, where for whatever reason doesn't have a seed, or so it's good to know how to do it. But for the most part, I don't want people to have to do it if there's like no benefit to them doing it, because I'm going to run the seeds no matter what every single time. getting to a reasonable size here. Every once in a while, I'll just pop this open, take a look at it. Now that I got the ink in here, I've been uploading those. Although I wonder, I don't even remember if I do. I don't remember if I ran fiber predictions on all of Scroll 4. I think I only ran them on all of Scroll 1. And I'm kind of curious. Another benefit would be to look at the fiber volume in here, because you could super quickly see, like, you know, when you're scanning through this right now. I have to find sheet switches by looking through this, and it's not particularly easy. It's not immediately obvious, especially in Scroll 4, where Scroll 4 is just a mess like this sometimes. And finding a good fiber to follow is a huge pain. Oh, I'm going to show this part too, because if any of you guys have done any kind of Scroll 4 ink detection attempts, you have probably also seen this, once this loads, this circle. There are a few of them in here, and it has literally thrown me off for every single time I look for ink in Scroll 4. This circle, I think it's the center of a ring artifact, but it has gotten me almost every single time that I look for ink. There's that one. There's a few spots in Scroll 4 that really throw me off every single time. That circle is the biggest one, though, because you see it right away when you open up that segment, and then you go, holy crap, there it is. Why would a circle be on a square? But it isn't anything. Or maybe it is, and I just haven't been able to put together exactly how it is something. There's a few of those. There's a few, like this stuff too. If you're zoomed out kind of far, you get this, like this looks like a U or part of a W. This could be like a part of an alpha or something like that. You get all these little shading things when you're way out here, and they all trick me every single time. I've thought I found ink on Scroll 4, I don't know, 30 times. I've been 100% confident that I found ink on Scroll 4, only to be heartbroken moments later. But that's the fun of it. Yeah, see, there's another circle right there. But I look for, like, organic shapes that go against the grain, that don't fit with, like, kind of a gridded flat surface like you would expect in papyrus, and it kind of shoots yourself in the foot sometimes. But it works really well when once you kind of get the pattern for it in, like, Scroll 1, you start to, doing that does work. It's just when you don't know what you're looking for, everything looks like ink. Like this looks like, this is another spot here. So this, that looks an awful lot like the, that like pie-like thing, right? On the fragment, is the wavy appearance. It can be fixed, yes, and it actually kind of fixes itself as it goes. The reason for that is you're trying to project a 3D image into 2D, and we don't have all of our corners everywhere, basically, and so the more it gets filled in, the flatter it gets. You can see in a lot of places it starts to get flatter, where it's very dense, but it can be flatter still, even than that. We've never run an extra flattening step, though. I'm very curious to see how that would look. But the more holes you have, if you're trying to parameterize or flatten a 3D object and place it in 2D space, the more holes you have, the less, like, sticking points it has, more or less. Like, the less you're able to kind of, like, push it and flatten it out. That's not exactly how it works, but that's the idea. Ideally you take a square and you turn it into a square. You don't take, like, a crazy shape and then try to form it into a nice flat rectangle. let's see where we're at. I think we'll pull up scroll 3 in a bit too. I'm just kind of curious here what this looks like. Yeah, and some of them you can see them some quite obviously. Some of those might need to be renormalized globally. That might be the slabs that you're seeing. So when it comes out, the first step in the reconstruction process, they have them in HDF5 slabs, and then they try to do a global normalization. And sometimes you can see the slabs are like sharp lines. Not all the time. You can see them in scroll 4 though. I'll actually just pull up scroll 4 again real quick and show you that. And I don't think they have like a downstream effect on like ink detection or anything, but they are distracting at times. And so when we're gonna have a lot of opportunities here in the very near future to get very good at that part. We're going to be scanning a ton of scrolls, and we'll have a lot of opportunities to experiment at like what parts of the reconstruction process we could do better, what parts are good as is. I mean, nothing is perfect yet, so we'll have a ton of chances here to try to get that a little better. Yeah, that's exactly what that is. That's the slabs. They weren't normalized properly, I don't think. So what you could do, it would be kind of hard. I don't know if they have that uploaded. I'll see if I can find them. I'll see if I can dig up the unnormalized slabs and get them renormalized properly. But that's exactly what that is, I think. That's the size of them. And you can see it in scroll 4 here. So you can see it if I zoom way out. You see this square, and there's one here, and there's one behind this that's got a bunch of holes, and there's one here too. Those are the slabs. And if I zoom out here, I have to wait for the other 2 volumes to initialize. And then I gotta hope I got a orthogonal plane in this bottom right one. Yeah, good enough. It's not quite orthogonal, but if you look right here on the right side, you can see the banding kind of. It's the same thing in the fragment that you're looking at. It's the normalization. Somehow, somewhere along the way, that global normalization went weird or something, and you get that banding where it was recomposed from a grid or from slabs into a full thing. It is a little tough though when you're trying to do ink detection, or when you're trying to look for ink, because you're looking at these intensity gradients and stuff, and something like this, you go, well, this is brighter here. Why is it brighter here? And maybe you think it's ink or something like that, but what it actually is just that part is brighter because it's not normalized the same way as the one below or above it, which is kind of a pain. So that's definitely something that we want to make sure that we get right on the next ones, and then go back and correct on the ones that we're able. That's strange. I don't know why that is. I don't know why in certain areas. I always run forward and reverse, always, because in a ton of segments outside of the grand prize region, it runs better backwards. It runs better backwards in scroll 5. It runs better backwards in a lot of smaller ones outside of the grand prize region in scroll 1. I don't know why, but if you have ones that you've ran it on before and you've just thought, hey, there's no ink there, make sure you run it the other way too, because there might be ink there. It shows up like in scroll 5, like you don't even get a letter, you get nothing if you run it the normal way, and so you assume that place is just blank. I'm kind of curious. So you got that. I'm curious to see real quick. I'm going to pull that up again. What I wonder is what does, in areas that are outside of our training data for scroll 5 or for scroll 1, does a full 3D model work as good or better in areas out of our training distribution? That would be interesting to see, so I'm going to check that out right now. I have a feeling that they probably will work better, especially like ones that are trained using masked data. So I masked out the air, because in a flattened scroll surface, when we're pumping the same labels into the thing over and over again, and we're telling it that air, those fibers, that is ink. And so it's really like one of the only ways we have to do it right now, because you can only really do annotation in 2D. But I think when we have enough labels, like we are telling the model that things that aren't ink are ink. And some of those are fibers that are particular to the scroll surface that we're working on. And so not only is the model learning what ink looks like in scroll 1, it's also learning what the fibers look like, and it's associating those. And so I think as we get, good labels everywhere in more areas, that we'll be able to train models that pick up just ink. And then that should generalize much better, because it isn't learning the fibers. They're all learning the fibers implicitly in some way, but it isn't learning them as directly or being forced to as much. I kind of forgot what I was doing now. Oh yeah, scroll 4, autogens. Oh, that's right, I'm in public full scrolls, not on community uploads. Download this quick. I have this on my computer, but I don't want to go into my paths thing. I don't think there are many. I don't think those ones have been X-ray scanned. Hannes might know. Somehow he knows everything about every papyri, but I don't know. I don't know for sure. I don't believe that a lot of them have been scanned, especially at the resolution that we've scanned them at. I'll see if he's and I can ask Stephen too. I wonder, there has to be some, but I don't know of them. I'm just waiting for these to download again. There are some projects that are doing it now, and there always have been some people using CTs on this stuff. It's not like we were the first ones to do it, but I don't know how many scanned it at quite such a high resolution, and I don't know how frequent it was. Yeah, I was wondering. I was asking you. So Kendra asked in the chat. I was saying the only reason I asked is because I saw you were in here, and somehow you have some knowledge of magically like every single papyrus on the planet. If you knew of any other ones that had been scanned, any other papyri that have been scanned with X-rays, maybe fragments or anything that have visible ink, she was seeing if we had any other things other than the fragments, because I think all the fragments, the problem with all the fragments and they were all from the Oslo process, as far as I'm aware, and so we don't have any ones that aren't to determine if that is potentially why they look so different or behave so different. There are some. Okay, yeah. I wonder. We'd have to see if we could dig some of those up, because I mean, I imagine that would be helpful. I mean, papyrus is probably similar everywhere under a CT scanner. And I got to imagine ink is somewhat similar everywhere, so I can't imagine it would hurt to use it as training data. But I don't know where that data is stored, or who has it, or if it's even publicly accessible. It is. Okay, interesting. I'm excited to see if we get really good ink models everywhere that are like generalizable to all the Herculaneum papyri, what that will look like if we run it on other ones like that. If they're generally like publicly available or anything. If we eventually have like a global ink detection model, which would be kind of crazy. Yeah, and that makes sense. I got to imagine that they all use something similar, though, right? Like, they got to have a few shared base components. Maybe not everything, but. And this is me, actually. I have no idea. Just in case anybody thought I was an expert on ink, I'm not. Only ink in this specific instance, and not even an expert there, only in what it looks like on 2 scrolls. Yeah, that makes sense. I mean, it was collected for who knows how long. So far we're doing pretty good here. We don't have any sheet switches, which is good. I've had a number of segments so far today that were bigger than this one, but I'm trying to get a full unroll of scroll 4 with no sheet switches. That's the goal today. I think we can do it. I think I have the data to do it. It's just a matter of running this, finding where it will produce errors, and then running it again. And then again. But I think I can do it in one day. I would look at any X-ray of papyrus sheets. Honestly, it would be interesting to look at any of them. I don't think any amount of extra data could possibly hurt to see. Yeah. Yeah, they probably have a couple extra ones too. I mean, I haven't really asked around, to be honest with you. I had that one group that I had talked to, but I haven't spoken with them in a while. I'd like to see more, yeah. There's just so many things going on, man. Like, there's so many things to do every day that, like, every time I think of, like, a cool, like, experiment to do or something like that, I run out of time. I don't even know what that one is. You might be more privy on the information there than I am. Here's another circle. That's scroll 5, isn't it? There might be another scan that I'm not aware of. So literally, I don't know of another one. That's not me playing either. I have no idea. There might be another one. I wasn't at any of the scans last year. I was just trying to do unrolling. I'll find out for you, though. I'm also curious now, so I'll find out and let you know. Because if there's another scroll sitting around, I want at it. This would be so nice if we had ink on scroll 4, because it would be so obvious immediately if these like were sheet jumps or anything, other than having to just kind of like look through it and hope. Just kind of a best effort right now. Typically you can tell because they won't reconnect. Like a densely connected one is pretty much always not a sheet jump, but it would still be good to know for sure. This stuff here, just like, come on. Just so much stuff that looks exactly like ink in so many spots of this scroll. Yeah, yeah, he's got some. He's, I believe he's working with some other group, but I can't really speak to his participation in that one. That sure looks like one. Here's another scroll model he made, a little less conservative. Yeah, I prefer. I actually prefer a noisier. I'd rather have a noisier model, to be honest with you. I think that if the letter is, if you're running one and this sheet is like black, that means your model's probably it's probably overfit, and it's probably being too conservative and missing things. I'd rather almost have a model that just marks more out. At least for this, you know, this isn't true on all data by any means, but for our data, I would rather my model predicts more than less, within reason. You know, I mean, I don't want my whole thing to be noise, but I'd rather have a little more to play off of than less. And that was what, you know, me and Elliot, when we did me and him and the rest of our team, when we submitted ours for our 2023 one, we purposely picked a model that was a little bit more noisy, because we figured that maybe the papyrologists, like in this example, you know, we don't know if this is a letter or not, but maybe this could help them. Maybe through the context of everything else, they could say, well, this is likely part of a letter. And so for us, we figured a little bit more noise is probably better for them than a little bit less noise, considering it's not like they're not used to dealing with imperfect surfaces as it is. It's not like the fragments that exist are perfect. So they've already got to kind of do some of that piecing together already. So it makes more sense to me to just have a little bit more clues. And I figure that's probably true for you as well. I'm not sure though. So I'm going to run this one out from the center, and I assume that it will die somewhere around here. And so what I'm going to do after this gets out there is I'm going to make a couple large traces out here and mark them as approved, and then hope that the tracer will catch those on the way out. It stops because it runs out of consensus, but if I mark one as approved, if I know that the surface is good and it doesn't contain sheet jumps, it will force the tracer to connect to it. And so I'm going to try to kind of coax it out this way. Scroll 4 is kind of hard because, well, I'm making it hard on myself in one case, in that I tried to cut out blocks that did not contain scroll data, that only contained air. And then in doing that, I wasn't as careful as I should have been, and I cut some blocks that actually contain scroll data, and you can probably see it here. That's the ink, so you won't see it on the ink, but where is the medial? Yeah, so you can see it in some of the corners here, and then as I come down in the scroll, or maybe up in the scroll, yeah, up in the scroll, I cut off the edge more than I wanted to, and the result of that is there aren't it doesn't wrap as many times as it should, and so the tracer starts to struggle in those areas. And I could, there's another one, and I could rerun inference on those spots, and I will. I'm just trying to see how far I can get without it. And it also happens that as the scroll gets closer to the case, it's only like half a scroll. Here I cut a lot out on accident, but the reason that looks more extreme than it really is, the scroll here is only like a C. And so as we get to these parts, it becomes harder for the tracer. It's trying to go around a wrap, and it's running out of scroll here, so it doesn't want to go there. So I have to kind of coax it. Yeah, polytryptophan, that's already like a couple initial letter guesses and such, and there's tons of that. So like you can run traces in scroll 1 and get like 500 times the training data that anybody else has. Like, to me, the being able to run these is like a significant advantage to anyone who doesn't when it comes to ink detection, or finding letters in other scrolls, or finding titles. Just having this open and running your models on it, training your models on other stuff, like you can generate yourself access to stuff that nobody else has quickly. Everybody else, if they're not doing this, has to wait for me to release stuff, which I'll be releasing a lot of stuff, but you could have more. And you can use the stuff I release too, as starting points for other stuff. I keep thinking that I'm going to open this ink detection model, and letters are just going to pop off the surface here at some point, and maybe they will, but it's more likely that they won't, because we've segmented most of scroll 4. Although we haven't done this. This is the first. I don't believe that we used these 3D ink detection models on these large segments of scroll 4 at all. Me and Ryan released them. Ryan released his first, and then I released mine not too long after. And we did some initial connected component analysis and such on them, and tried to pull the letters out in space and tell if they were letters or not. But it's really hard to tell if something's a letter on its own. It's pretty much impossible. It's hard to even tell if you look at a fragment or a segment that only has 10 letters. It's still hard to tell for sure if they're even letters. They just look like noise sometimes. And then when you see them in context, it becomes very clear that they're letters, but on their own, it's not always immediately obvious. Kind of curious to see what this looks like if we zoom in on it. I hope this czar is almost done, because this is what's slowing me down a lot. It isn't eating a lot of RAM, but my CPU is getting smoked right now. So this is taking way longer to run than it should. All my traces and my actually just opening things. Yeah, so there isn't anything immediately obvious there. This kind of thing too, I always think is potentially letters, because this does in scroll 1 a lot of time correlate with letters, where you can see kind of an edge of maybe the read as it pushed. You can kind of see something like that here, but scroll 4 has so much more texture than scroll 1 that it's not always, you can kind of see what it looks like at the bottom right here, like the end of a reed, and then it comes up and it looks like it rounds off here. But then you say that is, and then you slide your image 2 feet to the, or 2 inches to the right or the left, and you see another spot that looks exactly like that, and it couldn't be. So it's very confusing in scroll 4. I think, like I was saying earlier, though, I think, and this happened to me in scroll 1 when I first started annotating, and I think it's going to happen in scroll 4. Once you see it, you can't not see it. And we're gonna see the letters in these scrolls, and then we're gonna be like, how the hell did we not see that? It was so obvious, and it's gonna drive me nuts. But we'll get there. I'll be happy either way. I'm just looking for letters and looking for sheet switches at the same time. Got kind of a strange warp here. And this kind of thing too. Happens to be exactly 3 to 5 fibers high, which is exactly how tall a letter should be. But, where do you connect that? Maybe here, but it's hard to say. This scroll 4 has this too, which drives me nuts. This band, it's got a few of these that go across it diagonally, really thick, like they took a strip of papyrus to repair it or something, but it goes diagonally across the surface in a number of places. There's 4 or 5 of them, and they're really thick. It looks like they patched it or something. Then you get this one. What's cool about scroll 4 in some spots, and this is one of them, you can actually see the papyrus strip, which you can't do in most of them. You can actually see the strips themselves in a lot of places, as opposed to the fibers, which we're used to, which aren't really fibers so much as a lot of people keep thinking that when we say fibers, not you guys obviously, but whenever we first talk about fibers, a lot of times people think that we're talking about the strips, as opposed to the vascular fibers or whatever they are. But you can see the strips themselves in scroll 4 in a few places. I think this is one towards the bottom where it's really dark here, this line right here. You can see it really good in a composite, or if you look at a stacked fiber model, 2D fiber model. Did I not download the right thing? Come on, Sean, really? All right, we'll just go get it off our computer. I wanted to see, I forgot to look, when I pulled these up, I wanted to look at what the ink looked like if I did a projection of it. So these are all 2D layers basically, right? But if I projected them, I'm kind of curious what that would look like. And by projecting, I just mean taking all of the layers and then just turning them into one layer by taking some minimum or maximum or whatever you would want. And now we get a little bit of a different view at it. And if I turn it into a label, and this is what the model does for the like the grand prize model or anything. It actually predicts different layers and then it just stacks them. So we get a little bit of a different look than we did if we look at that individually, but not substantially, you know. You get a little more context, but you get a little more noise. I was kind of curious what that would look like. I hadn't done that yet. Like I said, I never actually rendered these out the same in different segments. I did it in some of the grand prize ones, but not in anywhere outside of that. And this is like, I wonder, yeah, there's crackle there. So what is it localizing after that? This is what's kind of nice about this model, because due to the masking that I did, is it marks the crackle like actual crackle versus as like a solid thing. Hannes, next time I do the next model I train, I will get you on video looks at non-crackle stuff. I promise you. I mean, it is seeing some stuff here that isn't crackle, but I'll show you some. And this makes it much easier to see it too when you can overlay the model to it. But crackle is still our primary signal, but there is stuff outside of crackle, and it's mostly in the form of shadows and textures, and you kind of get used to it a little bit as you do the annotation. A lot of talk early on was about how like this was never indicative necessarily of ink, like this right here, right? Because people would say that was air and not ink, but it isn't just air. The ink has an effect on the height or the depth of the surface, and when it was destroyed, it affected the surface, and you can see it very clearly when you go through them that they do leave an effect in the form of these like kind of shadow things. The problem is you can't use just those. If you use just the shadows, then you're going to be tricked. But the shadows do follow it in some cases, like it does here. I mean, you can very clearly see the curve that follows along where the ink is. What's interesting is this one hasn't marked what is, to me, the extremely obvious crackle, and this here is another extremely obvious. So this model clearly isn't very good yet, but it still does okay. And there's another. Let's see where we're at on scroll 4 now. I want to do, and I think I'm going to do it on Tuesday, the ink annotation in 3D, because I want to make a 3D model. That's something that we need really badly, is accurate 3D labels, because that'll make the 3D model that I have, or anybody makes, really good, if we can actually give it true, accurate 3D labels. The problem is it takes forever. I mean, forever, and it's really hard. All right, so far we're what, the full height of this scroll and 35% of the way there or so. Making progress. Not the full height over here, but the scroll doesn't really go to the full height everywhere. It's destroyed in many places. But I don't think, even if it weren't destroyed there, the bottom and the tops of the scrolls, when we do our traces, a lot of the time you lose some part of the, yeah, so this one clearly doesn't go all the way, but you lose some part of it a lot of the time because it just gets smashed on the top and the bottom so badly that at least anything that we have so far can't really like get through that. The tracer tries to make like has some like constraints built in that assume that it's like a developable surface, like a piece of folded paper or something like that. But in some of these areas, like you would be unfolding like a crumpled ball, which would be hard for anything with any constraints to get through. So we might have to come up with some kind of fancier stuff for those areas. But like, I don't know, for my money, if we can get 85% of the scroll height and most of the scroll width, we're doing pretty good. And then we can spend, the next 10 years getting the last 15%. But this process isn't like, I don't know. It's not as like interactive, I guess, as like manually segmenting, but manually segmenting gets kind of tiring too. It takes so long, and it absolutely destroys your hands. When I was doing a ton of segmenting in Cartez and VC last year, I was doing so much clicking. I had to buy a vertical stand mouse. My hands were getting like destroyed just from moving and clicking so much. And that's obviously an issue. So I'm happy to not have to click 900,000 times to segment this size anymore. I mean, I've got now 209 centimeters, which would have been probably a couple weeks of work at least for a segmenter who is very good to do. So if I can do that in an hour and a half, maybe, I'm pretty happy. Yeah, I saw those crazy. You showed me it. Yeah, that's right. Yeah, you showed me that thing. You sent me it was like some kind of. It was really cool actually. I have. Thankfully, it's gone away a lot. So the reason it was so bad was there was a time when I was doing a ton of segmenting. I mean, I was segmenting hours and hours and hours a day, every single day. In doing that, you're just clicking endlessly over and over and over again. And I didn't really have good like posture. So my wrist was in a bad angle, and I didn't really have a good setup on my desk. A lot of times I'd like sit on a couch and do it and have my wrist bent like this. Just everything. If you were to talk to I don't know what you'd call that kind of person, a physical therapist or orthopedic, I don't know, but whatever they're called, they would have never suggested the way I was doing things. And I probably could have made my life easier with like different shortcuts and such, but I just didn't. Yeah, those look really cool. You kind of just hold it and move it around. I did get I got like a hair in my eye between my glasses that I can't get out. I did get a Wacom tablet for ink annotation, actually, so I'm excited to use that. That's another spot that can kind of start to hurt my hand because you've got to hold the click for so long. Like, it sounds so stupid that would hurt, but it does eventually. But it does. I do feel a little obnoxious complaining about I click and I hold the mouse and it hurts my hand. I think my ancestors would be ashamed of that, but it is what it is. I'm telling you, one of these times I'm going to pull this ink volume up and there's just going to be a whole bunch of letters here. We're still doing good though. I'm pretty happy with this so far. I don't have any clear sheet jumps that I can see yet. I might have one here. No, that's not a sheet jump. So and I might have one here. This could be one. Let's see. Do we have consistent fibers? That looks like it probably is. What about down here? Yeah, that definitely is. So it's just flattened weird because it's got this big gap and this like weird overhang, and so it looks like a sheet jump, but it's not, thankfully. So we're pretty far. This is probably the largest segment I've made on scroll 4 yet that does not have any sheet jumps. Usually by now, some part of this would have diverged. I usually end up with consistent sheets for like, you know, maybe the middle band here or the bottom, but usually at some point, you know, this piece kind of diverges off and hops on the wrong segment and never reconnects again. So the fact that I've gotten this far so far is good. I'm hoping we can make it all the way. We can at least most of the way. I won't consider that quite done yet though, because there are a number of holes that I want to try to fix. So what I'm going to do is hopefully I can get this one to go like 80% of the scroll. You know, I imagine it's probably going to die out somewhere around here, because it'll just run out of like circular room to go. The scroll just turns into a C, and it can't really wrap around a C. It will. You'll see what it looks like when it gets out there. It's kind of like looks like a W sort of. So it'll try, but it will die out. But if I can get to about here, and then I'll run a trace going the other direction. So this one started from the inside and is going outside, and then the next one I'll run from the outside and go inside, with the hope that from a different angle or a different direction, it might not make the same mistakes. Maybe it gets this spot, it has a hole here, but catches this or this. And then I'll run that probably, forward and backward from different starting seeds 2 or 3 times, with the hope that, it's still going to make some mistakes, but maybe they're different mistakes. And then I'll combine them, and then we'll see what we get. I think that it's going to work out pretty good. Our first auto segmentation one had I think 4 or 5 of them, and you can use any number of them you want. You can use it. You could use 50 of them if you wanted, but your first one has to be the biggest one. That's kind of like one of your traces sets the bounds for the rest of them, so they can't go outside of that region, or they can't exceed that size. And then you want the ones that you use to be free of errors, in that, not that they don't have holes, but that they don't switch sheets, because when you go to merge them together, you essentially blast you got them wrapped in either a cylinder, and you basically, you shoot a laser beam through it and count how many times it goes through there. And that's loosely how you assign the winding number. And then its expected location to fill in the holes and match them all up. So if they're wrong, if you use incorrect ones, when you do that, your winding assignment won't be correct. But these holes are an open problem that I really want to give someone money to fix. I have that as an open thing. I'm actually going to probably post it on Twitter. These holes theoretically shouldn't be that hard to fill. At least for some reason in my mind, it doesn't seem like they would be. They probably are much harder than they seem like they would be. I haven't done a whole lot with trying to do in painting yet, although Hendrik did, and he's incredibly smart, so it must be more challenging than I'm giving it credit for. But there must be a way to fill them. This hole actually I don't think is a hole because of, that's just a hole. Okay, there are some spots that look like holes because of the tracing process, but there's just actually no papyrus there, so you don't get anything. But there must be a way to fill them in better than we are, and if we can do that, we're going to be in really good shape. The holes aren't that big of a deal overall in most instances, because they're a big deal, I guess, in some respects, but letters are so big that a lot of the time these holes are maybe a letter size. Like this hole, which looks gigantic, it's the size of one letter. And if we lose one letter overall, that's not ideal. If we lose a letter here, lose 3 here, 5 here, 3 there, maybe 5 right here. But overall, if we can get most of them, we're in good shape. But I don't want all the holes, because papyrologists are going to be angry at us if we give them just there's like some sentence here that's like perfect that they've been looking for forever, but there's just a stupid hole here. And I'm sure that like 2 words or 3 words probably has some huge impact on the overall meaning of it. I wonder if this is a coleus here. I see if I get that like really thick band, but I don't think it is. It's really hard to see them in scroll 4 without a 2D fiber model, because the fibers in scroll 4, you can see them decently here, but in a lot of areas you can't. You can't hardly see them at all, and so it's really hard to identify quickly if one is that or not. In scroll 1, it's really easy. You can see them immediately. This thing is funny to me. I've been so sure that this is like a chipped off bottom part of a letter. They might be, man. I'm telling you, in the center of scroll 5, whatever the heck is in the middle of scroll 5 was liquid at one point. There's bubbles in it, and it like drained down through where the umbilicus was and like settled in there, and it's full of really dense material, and it was liquid. Yep, thanks for coming. Hit me up if you need any help with any of this, by the way. But yeah, tar, sure, could be. Yeah, but this has a lot of it. There's a lot of like a significant volume of whatever it is in the middle of a lot of these scrolls. It could be, I don't know. I don't know where it would have come from. That's the thing. I mean, recondensed tar, maybe it's that. I don't know. The umbilicus you wouldn't think would, I mean, it's wood, right? I don't know how that would turn into anything liquid. So maybe the tar is from, where does the tar come from? If you do think it is the recondensed tar. Oh, does it? Well, maybe that is what it is. Yeah, it could be. It's as good a theory as any as I got, so yeah, why not? I mean, that's an interesting theory on it. I don't see why it couldn't be that. It'll be. I'm surprised that none of them have ever. Well, I guess we've never. Well, they opened them up at some point, but I guess it was a long time ago when they were cracking these things open, and maybe they just never thought to test them then. But I mean, that substance is present in all of our scrolls, and so you would think they would have found it in the ones that they cracked open, but maybe they just didn't think anything of it. what I think, now that you say that recondensed tar, let's pull up scroll 3. Scroll 3 is covered in. Yeah, I don't want to see any wild boars. I'm good there. Scroll 3 is covered in a very like thin layer of like kind of like greasy, oily looking stuff. Let me try to find a really good shot of it. Like this right here. All this stuff is all over scroll 3. It's on scroll 5 as well, and it's on scroll 4 in some spots, but on scroll 3, it's everywhere. And it's very distracting. Just like here, it's all over. And scroll 3 looks different as well. I think this is a letter right here. I actually think letters on scroll 3 are going to be very easy to find once we have all of this segmented. There's so many spots on scroll 3 that look like letters to me, like clear letters, but there's never a big enough surface to like actually put them together. But scroll 3 has a lot of this stuff, and it drives me nuts because it's so distracting. Scroll 3 also has this really annoying thing. It cracks like this everywhere. These are like cracks in the papyrus surface, and maybe that's what's happening here. Is it's evaporating its tar and then drying out and cracking. Could be. Maybe that's what all that stuff is. Maybe this was made with a papyrus that's more oh yeah. Yeah, that type of thing is all over. That little pinprick circle kind of stuff that you see if you were to slice a bubble in half. It like bubbles and then you get like a sphere there. It happens like all over, and it's very distracting, and it could be very well what it is. I don't see why not. I would like if someday we could get an answer to it. I am wondering what it is that I'm looking at most of the time here. I would love to know what that actual material is. But here we got some. This I don't know if that is. This is like another thing that you see in a few of them. It's like a really small piece of whatever that like more like plate like stuff is, but it has a different texture. I think this is a letter here too. I think that the crackle in scroll 3 is like almost see-through. Like you can see it here. And it looks very similar to don't make me sign anything, please. Thank God. Now I know this is a electron microscope image, but somewhere in this thing, yeah, I'd probably be better off if I just searched electron microscope. There. But in this, it's almost see-through, which it isn't in scroll 1. And obviously this is much smaller, and the imaging method is different, but still. No, I know that, but I'm just saying, I'm saying it's within the realm of possibility that the crackle, the ink could look different on a different scroll. It could be more see-through or less see-through, or there are different imaging times, different, same resolution, but you know, I'm sure there's a lot of variables there that they could make the crackle more or less visible. And I don't know that that's what that is. To me, it looks very similar to crackle. It's just more see-through. I don't know that it is a letter, though. You know, we won't know until we find the rest of them, or at least a large enough part. My ink detection model does not light up a bunch on this scroll. Ryan's does light up a bunch, but that's because it lights up all that grease on the scroll surface. All that, and that's the same thing that happens with the GP model on scroll 3. It lights all that grease up, and then you can't kind of see, like, there's a lot of stuff that looks like it could be letters with that model, but there's so much noise that you can't really tell. This stuff, this stuff has always confused me on scroll 3 too. I mean, it's too small though. Like if I zoom in here, that's what, 2 fibers or 3 fibers? Well, actually, I mean, that would be 3 fibers tall. So that would be, they're a little more than 3 fibers. So like 3.5 centimeters, I think, or millimeters, not centimeters. I think 3 to 5 is our standard on scroll 1. So that's within the realm of possibility there, that those could be rows of letters, which they very much look like rows of letters with a column. Let's see where scroll 4 is at. We're still chugging at 287 centimeters. And I wonder, is my reshape done yet? Yes, finally. So now I can turn it into an OME-ZAR, which will also take a long time, but then we'll have Ryan's model in scroll 1 as well, and I can share that too. This one is where did I put it now? Oh yeah, scroll 1 writing .zar transposed. That's what I'm looking for. And the bytes 1 flag there, if anyone ever wants to run this script, is Ryan's one is in uint 16, and I'm converting it to uint 8. So I'm doing 1 byte per value instead of 2. Oh, I opened up scroll 3 again. I meant to open up scroll 4, and I opened up scroll 3. I'm gonna look at this for probably, I don't know, 5 more minutes, then I gotta get going. I'm gonna keep it running tonight. I'm hoping by the end of the night I'll have a full unroll. We'll see. We still haven't gotten a sheet switch, which is freaking awesome. This looks like it is. This is all like intermediate patches that get screwed up by that Z-flip. Thankfully, we are, if we punch our thing here and we look at our other axes, we don't mark anything there, and that's this hole, probably this one. It's one of these holes, but we don't skip any sheets. We've got, you know, a piece here, 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 and here. So we've hit every sheet. So we're in good shape. We didn't skip any, even though it looks kind of crazy. We just get a hole, which isn't ideal, but better than a sheet stitch. And we've got, this is another easy way to tell usually is, this spacing should be linearly increasing. You shouldn't have like a huge, like giant space here and with a huge bottom or something like that as we go. This is gridded because I cut the bottom of this off. I didn't want the bottom of the scroll case. Let's see. I hope we're not stuck. No, okay. I can't remember what parameters I started this with. 8 and 4. So that could be why it's very slow. Usually these traces are much faster. Granted, I'm doing a lot on my computer right now, which influences the speed of it, but I would have expected it to be a little bit faster. I do want to see quick though how densely seeded scroll 3 is, and see if I would be able to start some traces on that later or tomorrow morning. The scroll 4 unroll that I'm trying now is 2 reasons. One, I mean, we need more and better data on scroll 4, but also just to see if we can. But scroll 3 and scroll 5 are the ones I'm interested in the most right now, because those are the ones that have, to me, the most promising like directions on them. But it would be pretty huge if we could unroll the whole scroll. I mean, that would be big. Unroll the whole scroll like mostly automatically, at least. I've done probably like 20 masks in this total, so it would be like 99.8% automated. I'm basically just monitoring it. I believe, yeah, I am in the scroll 3, so I want to see the raw data. What I'm looking for here is to see if it's densely seeded enough, or if I have to run more seeds, and the answer to that is I need to run more. So I need this area to fill in a little bit yet, but that's about it really. I don't need too much more. I could use a little bit more in the bottom here, but it's this kind of like this area right here, and I imagine that the predictions are probably fine there. Let's find out. Yeah, I mean, they're not perfect, but they're more than good enough for the patch to get through. So I just need to run it again, and it'll figure it out. But then we should be able to run some pretty nice traces on scroll 3 tomorrow. Right now, all of our ones in scroll 3 are like, if I can click on one, they're like this, like kind of like, parts and ones. You don't ever get like a really nice solid sheet of papyrus, which makes it really hard to tell if you've got letters or not. You'd like to have the context of like a column or something like that. So I'm hoping I can get one solid piece here. I'm going to check one more time on scroll 4. Then I'll probably take off for a little while. We are still not jumping sheets. And we are very near the outside, so that's where it starts to get tough. We only got, what, 4 sheets left before we hit the outside, so we're nearing the end of this one anyway. So, okay, I think I'm done for the week, but maybe I'll do a little bit of streaming tomorrow because I'm going to be plugging at this either way, and people might be interested in it. So, have a good night, you guys. Take it easy.